All right, guys. So today I want to take you through the logic of association rules and introduce you to market basket analysis. Okay, we use Python like in pretty much all my examples with extremely few exceptions. I use Python Jupyter notebooks for everything I do here. I deviate a little bit. I created one video about VBA, mostly for Excel, little Access, Microsoft Word, things like that. And I have a couple videos about SQL. I think these tools are somewhat important for data scientists, and if you have that these kind of tools in your toolbox, I think that's very nice. But really, the majority of it is really Python. Probably 99% is really Python code. Okay, so we're gonna stick with this. Association rule mining is really used to discover relationships between items in a data set. Okay, so association rules are basically statements that say if this is true, then something else is true. If A, then B. If A happens, then B will happen. Okay, and there's other rules too. We can look at what is it called? Causal inference. Yes, causal inference. You can say if this happens, then this happens. You can say why something happens, right? What happens is very important. I think the why something happens, is even more important. My wife and I were talking recently. We went for New Year's Eve to a restaurant, and most of the restaurants that we walked by were open. I was kind of surprised because I haven't seen a lot of open restaurants. I remember years ago, 10, 12 years ago, there were hardly any restaurants open. Okay, and we live in New York City, where the city really never sleeps 24/7. You can go out for food if that's what you want to do. Okay, so but the exception was New Year's Eve. A lot of restaurants were open, but we noticed recently, this year for sure, and the last couple of years, a lot of restaurants are open New Year's Eve. Now, I don't know exactly what is causing that. Is there a cultural shift? Is there some kind of um, mind shift? People used to stay home on New Year's Eve. Now they want to go out all of a sudden. Or is it because apartments are getting smaller and smaller in New York City? That is the trend. If you look at apartments that were built 15, 16, 17 years ago, they tend to be much larger than apartments today. 15, 16 years ago, nobody went out for dinner on Christmas Eve. They stay home and entertain their family and friends. My hypothesis is, and I could be way off here, but I think apartments are getting smaller and smaller. If you have your family and friends come over to your place, you can't host them because the place is just too damn small, right? There's no room for 6 or 7 or 8 people to get together and sit down. So you go out to dinner, and restaurants accommodate the need, right? So they open on New Year's Eve. Now, I don't know if that's actually why restaurants are open on New Year's Eve, but that would be my guess. And with causal analysis, or causal inference, you could look at that kind of thing. So this is somewhat similar to that, slightly different. We're looking for patterns or relationships in the data. So if a person buys pasta, will they buy pasta sauce? Yeah, there's a high correlation between those two. Will they also buy chips? If you buy pasta sauce, we also buy chips. I don't know. Maybe yes, maybe no. If you buy burger buns, we buy burgers. Probably buy the buns, buy the burgers, buy the ground beef, buy the buns. Right? Those two are going to be highly correlated. Peanut butter and jelly, highly correlated with bread. Peanut butter and jelly and frozen vegetables, probably not. Probably not a high if then be relationship between those two. Okay, so that's what we're going to look at. So I have some grocery data here. Let me go ahead and refresh the cell. Control Enter is going to refresh it. I'm going to print everything in this list. This is data structure has square brackets around it, so it's a list. We have a few different data types or data structures. We have data frames. I use those a lot. Lists, dictionaries, I use a lot. Sometimes tuples, but not so much, right? So I like working with lists. They're mutable, they're changeable. You can add and delete pretty easily. So lists are pretty flexible. I like this. So I'm going to go ahead and create a data frame and look at a k-means clustering method to see how many clusters I need to create to show me what are the relationships between these different items in my grocery basket. I think there's 100 here. Pancake mix and syrup, I think, are going to go together. We'll see in just a moment. But bagels and cream cheese and pancake mix and syrup, is that going to go together? I'm not too sure, but we're going to find out in just a minute. So I'm looking at the clusters between these different words, different grocery items, and I'm going 1 to 20. Okay, so I'm going through 20 iterations. You can see it's plotting on the chart. Now I'm not actually getting an elbow curve. An elbow curve kind of bends at a certain point, and where the bend is at a maximum, you can see right here the number of clusters in this example is k. Number of clusters is 4. where you see the biggest bend in the elbow. It's kind of like an elbow, right? Your elbow is kind of swinging around. It kind of looks like an elbow, I guess. They call this the elbow curve. So we're looking for an elbow bend, but they have no bend here, right? And I put this up pretty high, up to 80, and there was still no bend. So I don't think this type of clustering is going to work for us. There's another way to do clustering. You can use a silhouette method. And here you see a big drop off. So a big bend here is around, I think, about 20 or so, although it kind of flattens out. This looks a little bit weird. And again, the silhouette method, like the elbow method, I just don't think it's really working in this case. In some cases, it's going to work. In some cases, it doesn't work. Right here, I don't think we're getting the optimal number of clusters. Actually, let me refresh it. I didn't even do that. I don't think we're getting the optimal number of clusters here. So I don't know how many clusters to create for this data, but I'm going to pick 20. Okay, it kind of looks like 20 over here, even though this isn't really working, and this thing is like kind of linear diagonal pattern, so that's not really working. I'm just going to pick 20 and just see what happens. I can't say this is optimal or suboptimal. I really don't know. I'm just going to create this and go with it. So based on K-means clustering and how similar words are to each other, or how dissimilar they are, most similar will go together, dissimilar go into another cluster. So we have cluster 0, tomatoes, sugar, baking soda, brownie, soda, plastic wrap. These go together. These words have a high association, right? The association rules are pretty strong for these. Cheese, apples, carrots, onion, tea, hand soap, aluminum, foil, and cat food go together. Apparently, I mean, that's not super intuitive to me, but according to the KMeans algorithm, that's how this works. Peanut butter, chocolate, that goes together. Paper towels, dog food, baby food. I guess that goes together. A little bit skeptical, though. I'm not super convinced that this is working. Then we look at cluster number 4. It's 0 based, so we always start with 0 and then increment up by 1. So this is actually 4, even though it says 3. Dip, fish, coffee, frozen pizza, ketchup, laundry detergent, dish soap, and bagels. So I would say these two definitely go together: dish soap and laundry detergent. Bagels, maybe, maybe not though. I mean, I'm not super convinced here. Okay, but we can determine that there is some kind of poor clustering. There's not clear separation, and the number of clusters is indeterminate, right? We don't know if it's 10, if it's 20, is it 60 or 80? We just don't know, right? But grouping milk, eggs, cheese, and butter into the dairy category, that would be ideal. That's what we're trying to achieve, right? So I don't think by running this clustering algorithm, I don't think we're there. So we're going to try a different method, and that's fine. If you don't get what you're after the first time, it's totally fine. Data science is called data science, right? Because you run different experiments and you don't know what the outcome is going to be when you start, right? So it is science, and you create a hypothesis and you try to prove your hypothesis, or sometimes you can't prove your hypothesis, right? So it's disproved, but that's fine. You would change your hypothesis to match your data. You would never change the data to match your hypothesis. That's kind of crazy, but if we create a hypothesis and we can't achieve that, that's fine. We'll just try a different approach, right? So here's the takeaway. We're looking for some type of dairy category if we get these items in our grocery list. Okay, so let's move on to the next method here. So that was K-means, and that was it. That was just a simple K-means. So K-means is great for some things. It's not great for other things. Now we're going to try TF-IDF vectorizer. So term frequency, inverse document frequency. That's what this stands for. We're looking for the frequency of terms in a document and the inverse of the document's frequency for these terms. I'm not going to get into the whole the whole history of this type of thing. You can look it up, but this is another way to handle text. And to vectorize the text, we're converting text into numerics, right? So we're converting text into numbers, and we're going to go ahead and run this and analyze the numbers to, again, look for similarities or dissimilarities. So we have sugar, cluster 0, coffee and coffee creamer. Those seem to go together. Coffee bags and garbage bags, I would say that goes together. Here's cluster 3, pasta sauce, tomatoes, cucumbers. This is a big one. So cluster 3 has most of it: baby food, bagels, and syrup, and cat food and popcorn. So it looks like everything gets dumped into cluster 3. That's kind of just like a garbage bag of terms here. Then cluster 4 is lettuce, ice cream, and cream cheese. I think these go together. Cake mix, pancake mix. Yep. Conditioner, ground beef, and formula. So these kind of seem to make sense. Cluster 3 seems like it could be parsed out in a more detailed fashion, because I think a lot of things are just getting jammed into there. But That's okay. That is what it is. Again, we're trying to prove a hypothesis. I don't think we've proven it yet, so we'll try a couple different methods. TF-IDF is term frequency, inverse document frequency, right? The purpose is to process text and transform them into numerical features or vectors. Okay, a numerical representation of a text word is a vector. This represents the importance of the terms in the document. Okay, so inverse document frequency measures the unique or rare terms across all documents, and term frequency is how popular does this word, how popular is this word, how popular or how frequent does it show up in a body of text. Okay, so that's good. Let's try a pre-trained model now, and we will rerun the analysis. Now we have a slightly different hypothesis, right? The hypothesis is to use a pre-trained model. This is a spacey model. It has been trained, I'd have to look at this, I think on at least several million different data points. Like ChatGPT has been trained on billions, right? When you put in your request to ChatGPT, it spits out the results. It's been trained on billions and billions, I think hundreds of billions of different features. This one right here was trained on, I don't even know, like 8 to 10 million, I'm guessing. So way less than ChatGPT, but that's fine. It runs pretty fast. Let's see what kind of result we get when we fire this thing off. So instead of TF-IDF, we're using a pre-trained model, and again, we're putting in the same terms that we had before: pasta, pasta sauce, chips, burgers, buns, ground beef, all the way through bagels, cream cheese, pancake, and syrup. Okay, so here's our clusters: milk, flour, sugar, baking powder, baking soda, syrup. So that seems to make sense. So this pre-trained model, right off the bat here, I think this is working. We have bird seed, baby food. Do these go together? I don't know. According to the model, it does. Dog food, cat food definitely goes together. Bird seed, dog food, cat food. These things go together. Coffee, tea, energy drink. I think this makes sense. This one, it looks a little bit weird, baby food, but okay, let's go with it. Chips and dip definitely go together. Burgers, buns, hot sauce, relish, French fries, vegetables. This is all barbecue food. Definitely goes together. Pasta, pasta sauce. Barbecue sauce, mayonnaise, mustard definitely goes together. Oats, apples, bananas, yep. Jelly, cereal, ice cream, yep. Soda, juice, wine, whiskey, yep. Water, toothpaste, cheese, butter, bread, and then bagels. So maybe 8 and 9 could go together, but that's fine. This is what it is. The pre-trained model is giving us 10 different clusters, and this is how it shakes out. So I think this looks plausible. This looks pretty good. Here's another pre-trained model. This is Encore Web Logic, Encore Web Logic. But wait, what is different here? Oh, yeah. Okay, so now instead of just doing traditional K-means clusters, we're doing clusters based on network analysis. So I have a few videos on network analysis. This is pretty fascinating. You can go ahead and run this code, and then, of course, dump in your own terminology and create your own clusters and your own network analysis, and you'll get your own results. I tried to make these videos generic enough so you can just dump in whatever you need and get the exact results that you need for your analysis, right? My analysis is going to be different from yours. I'm trying to make this specific and, oops, what happened here? Specific and illustrate the point of how these models work and how the network analysis works, how the K-means clustering algorithm works. But I also try to make it generic enough so you can plug in your own terms right here and do your specific analysis for whatever it is you're working on. So let's run this network analysis and see what the result is. Okay, it's running. Let's be optimistic here. I've had a couple of these things fail, but I tested all this before I turned on the recorder here, so it should work. Although my laptop is a little bit old now. It's getting tired. Getting a little bit used up. Probably need to get a new one soon. Although it is a solid state drive, it's pretty fast. I mean, it should pull through here. Let's see what's going to happen. Let me just tell you the outcome here. Assuming this does work, this is K-means clustering. The purpose is to find groups of data points that are similar, and they will be clustered together, or if they're dissimilar, they will go through their own separate cluster, right? Let me go back here, finish up the notes here for my findings. The K-means algorithm looks at the K clusters. K is a number, right? So this could be N clusters. N could be any number. K is any number, right? From at least one would be weird. Everything would just be clustered into one giant cluster, but typically 2, 3, 4 up into whatever the k-means based on the elbow method or the silhouette method that we saw at the beginning. So I think here we're using, I think we have 10 different clusters, and it works with numerical data only. That's why we have to convert all of the terms or the strings into numbers, right? And then we can measure the distance or the similarity or the differences between those clusters, right? So let's see what the computer came up with. So we have some nicely arranged clusters here. And if I zoom in, this is pretty cool. This is why I like this PyViz library. We have soda, whiskey, beer, wine, and juice. And this is pretty interactive. If you pull it down here, it pushes the other guys out of the way. And then this guy is coming through. Get out of here, buddy. You have to move because you're taking up my space. So let me zoom in on this. And I think we'll see terms that are pretty much pretty homogeneous here, right? So we have eggs, beans, relish, burgers, buns, chips, canned soup, canned beans, frozen vegetables. So that seems to go together. I think that makes sense. Pepper, potato, spinach, lettuce, broccoli, cauliflower, pasta sauce, pasta, ketchup. Sounds like a barbecue. We're doing a barbecue here, and we have a little pasta on the side, maybe a macaroni salad for the barbecue. Fish, dog food, cat food, coffee, energy drink. So I think that's working. Granola bars, candy. These are all snacks, brownies, chocolate ice cream. I think it's working. I'm pretty happy with the outcome here. Bread, peanut butter, pickles, butter, cracker, cream cheese, yogurt. I wouldn't put all of those ingredients onto the bread and then start eating it, but I've heard people eating pickles and peanut butter together and making a sandwich out of that. So I think those go together. And what do we have down here? Orange, carrots, cucumbers. So a lot of veggies, fruit and veggies down here. Okay, so I think it's working. I think we got some nice results here. Okay, let's try one more. Now this is kind of the main point of the topic here. These are association rules. So you saw a couple different methods to try to create relationships between data using the pre-trained model, using the k-means clustering algorithm, right? So Apriori is going to show us if something is true, what else is true. If we buy pasta, will we buy pasta sauce? Probably. It's probably true that we're going to buy that, right? So here we have the frequent item sets, right? It creates item sets, and then it creates a pretty large data frame of 3,353 rows, 2 columns, and these are the results. So antecedent and consequence. This is what happens first. This is what happens next. This is the if. This is the then. If burger buns, then cucumber. If cheese, then barbecue sauce. If peanut butter, then aluminum foil. If aluminum foil, then peanut butter. Okay, and we have weights for all of these antecedents, right? So it's going ahead and creating a whole bunch of combinations of words here, and then looking at how strong these relationships are between the words, right? So here's the grouped items. Ultimately, we have burger buns, and cucumbers go with burger buns. Cucumbers go with burger buns and onions. Barbecue sauce goes with cheese. Barbecue sauce goes with cheese. Okay, so if cheese, then barbecue sauce and cheese. If barbecue sauce, then barbecue sauce and cheese, and so on and so forth. If cat food, then cat food and toilet paper. If garbage bags, then garbage bags and diapers. And if diapers, garbage bags and diapers. Okay, wow, it's a mouthful. So let's go ahead and plot this now so we can see the visual, because picture is worth 1,000 words. And here we go. We get the relationships. I color coordinated everything, so the colors are the same if these guys are associated together. Okay, you're not really even clustering. These are more association rules. We can say cheese and barbecue sauce, popcorn and carrots. Those go together. Chocolate and formula. I think that is baby formula. Diapers and garbage bags. Probably diapers and baby formula would go closer together, but not too sure. Not based on the algorithm, right? So peanut butter and aluminum foil, and we have burgers, cucumbers, and onions, and down here we have Ziploc bags and body wash. Okay, so I mean, I think it's working. Some of these totally make sense. A couple of these seem a little wonky, a little bizarro, but you know what? It is what it is. We tried the k-means algorithm. We tried a pre-trained model, and we tried association rules. So I think the pre-trained model worked pretty good. The k-means really didn't, based on what I'm seeing here, but I think the association rules kind of works. I think maybe some kind of hybrid combination of a pre-trained model and association rule technique might work even better. You might get more refined results, more evolved, more interesting kind of outcome if you do something like that. I didn't do that type of analysis. I kind of just kept it into separate buckets here. But if you do some type of ensemble learning, like some of these machine learning algorithms are ensembles, random forest, XGBoost, of course, are ensemble, you might get even better results. I did not do that, but that's okay. We're just keeping it crisp and tight today and looking at 3 different separate and distinct types of analysis here. So here's the a priori association rules. We look at if and then if something is true, then something else should be true. The a priori algorithm finds frequent item sets, which are groups of items that appear together most often, right, using a threshold, and that is the frequency of the items appearing together. That's how that works, okay? So if a customer buys X, they will also buy Y. That's essentially what we're trying to prove here. In summary, we have a TF-IDF vectorizer, the KMeans clustering methodology, and the a priori association rules. I have all my notes down here. I'll leave it to you guys to go through this. I'm not going to walk through it and spoon feed everybody. I don't think that's necessary, but you have all the summary here of everything that happened above. So that's pretty much it, guys. I'm going to wrap it up in less than a minute here. Hopefully you learned a couple new things today. I learned a little bit putting this together. I think it's pretty interesting. I think this stuff is actually quite fascinating. So I put these videos out, trying to get on average about maybe 1 per day, give or take. I think I'm a little bit behind on that goal, but I could pick up the pace a little bit. I could get 2 or 3 videos out per day, I think, going into the new year. It's December 28th, 2024 now, so we're kind of at the tail end of the year here. I think I can level up a little bit and maybe do 2 or 3 videos per day, maybe even 4. I think my record at one point was 10 videos in one day. It's kind of a marathon there. So that's it. Yeah, I'm gonna wrap it up. Thanks for your time today. Enjoy the rest of your day and keep an eye out for new videos, which will be coming out very soon. Thank you, everybody. Goodbye.